Hey guys, so I made a video a while ago about the fourth dimension. I have it on my other channel, put a link down below, and got some pretty positive feedback from that, and a lot of people were asking if I can make another one. Alright, so I'm going to be doing that today. So today's video is going to be on tachyons. What are tachyons? They're a hypothetical particle that travels faster than the speed of light. I'll explain later. So why do they travel so fast? Tachyons have what's called negative mass. This is not to be confused with buoyancy or lift. They are actually on the other side of the proverbial graph of mass, let's just say. So why am I talking about tachyons? If we were to prove that tachyons exist, they are hypothetical, as I said before, but if we were to prove that they existed, we would prove the many worlds theory. What is the many worlds theory? Well, it's the theory where there's multiple universes, and in each one, a slightly different scenario of what's happening right now is going on. There's a situation, or like this, basically a mini situation thing. I forget, I'm losing the word. Scenario, there we go. There's a scenario called Schrödinger's cat, if I'm saying that right, where you put a cat in a box with a bomb, basically. 50-50 chance that the cat dies. We don't know what happens until the cat, or we open the box and see the cat. So why is this relative to tachyons? Well, the many worlds theory is that, like, to our understanding, we open the box, the cat is dead. That's predetermined because the bomb went off or didn't go off before we opened the box, right? It was predetermined even though we saw it after. In the many worlds theory, the universe branches off into a parallel universe, one of which where the cat dies, one of which where the cat lives. Vsauce, I believe it does. Vsauce and Minute Physics, they have great channels, and they both feature this scenario. But yeah, so the universe branches off into a parallel universe, one where the cat lives, one where the cat dies. So as you can imagine, there's billions upon trillions of whatever that number is, of scenarios that could have happened throughout the entire history of everything. So you can imagine there's a lot, and I mean a lot of universes. Alright, so Einstein said nothing can travel faster than light. How could he overlook this? Although nothing with positive mass above zero, could travel faster than light, this is not the case with negative mass. Matter with negative mass has the exact opposite of laws of physics as we commonly are taught. Their laws are basically mirrored of what ours are, just like math is mirrored when you put a minus sign in front of it. See what I'm saying there? Although matter with negative mass cannot travel slower than light, as the energy dissipates, it speeds up. Here I have a graph. So I don't know if you can really see this. Here, I'll just check. Alright, so the line going across the center, it's green, I don't know if you can see that, is the speed of light. This blue line right here is speed. Slow, light speed, extremely fast. This is the energy meter. This line right here, where when you get to light speed, you have tons and tons of energy, and the further away you get away from the median, which is light speed, the less energy you have. So this pink line right here, pink line, here I'll see if I can turn down the brightness so you can see a little bit better. Alright, so this pink line right here represents us, and so as our energy increases, we get closer to light speed, see our speed goes up, but as we lose energy, our speed goes back down. Exact mirror for things with negative mass. As their energy levels rise, they get closer to light speed, but which is slowing them down. So as they have more energy, they slow down. But as their energy dissipates, they actually speed up, because they're getting away from light speed. Pretty cool, huh? Alright. So yeah, that's really cool. Alright, so they go faster than light. Doesn't that mean they go back in time? Yes. Negative mass, or matter with negative mass goes backwards in time relative to our dimension. There is no normal time dimension. It can be flipped if you want, and it really doesn't matter. Just as we appear to be going backwards in time to things, to their time dimension. Try to stay with me here. I know it's pretty hard. Anyways, so if we could emit and detect tachyons, does that mean we could send information into the past? Yes, but it is very, very limited, and just a terribly inefficient system. Alright, so because tachyons need to travel very, very, very long distances in order to actually go back a measurable amount of time, I'm talking a very, very long distance here. The distance between Earth and Pluto, if they were to travel that distance, they would only go back in time 5 minutes. Very long distance, right? Alright. So, because of the super long distance needed, we would be so far away from Earth that we wouldn't need to be communicating with them. Okay, so hypothetically, we found a practical use for this communication. If we actually did have a tachyon emitter and detector, it would open up so many paradoxes. One's very, very similar to the kill your own grandfather paradox. Google it if you don't know what I'm talking about. So, like, the simplified version of the kill your own grandfather paradox is, something happens, you need to go back in time, kill your grandfather. Hold on a second. If you kill your grandfather, that prevents you from being born, and therefore prevents you from going back in time to kill your grandfather. Paradox. Something's up, and we don't know how to solve that problem. Alright, anyways. So we would have very, very similar, if not the same, problems with the tachyons going back in time, sending info, blah, blah, blah. Okay, so here's an example of a problem. We have a tachyon emitter and detector station on Earth, and another one on Pluto. Earth, sends a tachyon beam to Pluto at 12 o'clock local time. They tell Pluto to expect it at 11:55. In order for them to let us know that they received it, they send another tachyon back. The problem being, 5 minutes negative time there, 5 minutes negative time back. That means we get a tachyon 10 minutes before we start. Alright, so that's all cool, whatever. So if we emit a tachyon, if we receive a tachyon and the alarm from the tachyon detector goes off, makes the person manning that station spill his coffee and break the tachyon emitter, we wouldn't be able to transmit the first tachyon. Therefore, the people at Pluto would never receive that tachyon and would never transmit one towards Earth. Again, paradox, because if they never transmitted one at Earth, the alarm wouldn't have gone off and wouldn't have prevented the person to spill their coffee and break the emitter. So where did that tachyon come from? The only theory that covers absolutely every problem in that scenario is the many worlds theory. It does actually prove absolutely everything in that scenario, down to every little detail. Although this theory is absurd, it does happen. That tachyon in the theory came from another universe. Again, very, very slightly different from ours, where we didn't spill our fucking coffee. Kidding. So, if we could actually detect tachyons, then that means there are other universes out there, which means that in some other universe, you got that Xbox you wanted for Christmas. Alright, thanks for watching. I hope you enjoyed the video, and as always, come back later.